machine can found the y predicted value, you can compare actual y value and predicted value, then you can get the results. So step number 1 for import package, step number 2 for read data from dataset, step number 3 for splitting data into x and y, step number 4, please listen carefully, x train comma x test, y train comma y test, which is equal to the method train test split off, which is available inside the package sklan.model selection. So train test split off x comma y comma test size as 2. Test size 2 in the sense 20% for testing and 80% for training. So step number 1 for import package, step number 2 for read data from dataset, step number 3 for splitting x and y value, splitting x and y value, step number 4 here 80% data which is taken for training, 20% data which is taken for testing. So with the help of a single function, train test split off, we split our data into 80% taken into training and 20% taken into testing. Now I have 4 variables, x train, x test, y train, comma y test. X train and y train having 80% data, x test and y test having 20% data. So x train and y train, the variable which is holding 80% data, x test and y test variable which is holding 20% data. 1 second please. So x train and y train which holding 80% data, x test and y test which holding 20% data. So that's the use of train test split off, randomly which taken a value. Now I will entering into my 5th step. So step number 5. This is for step number 5. So I will take sklan.linear model package. I will take the class linear regression. So regressor equal to linear regression. So which point? The handler which pointing my constructor. So regressor.fit, I will pass x train comma y train. 80% data was passed to this model. Now my model is ready. Then step number 5, model is ready. Regressor.fit x train comma y train. 80% data was passed. Then my model is ready. Then regressor.predict, I can pass only x test value, which can predict the y predicted value. Regressor.predict x test value, which can predict the y predicted score. So you can print the actual y test value and predicted y predicted value, which can print the result. For example, actual value is 20, my predicted score is 60. Actual value is 27, my predicted score is 33. Actual value is 69, my predicted score is 75. Actual is 30, predicted score is 26. Actual is 62, predicted is 60. So this is what my machine learning algorithm works. So I am repeating again. Step number 1 for import package. Step number 2 for read data from dataset. Step number 3 for splitting x and y value. Step number 4 for 80% data for training and 20% data for testing. Step number 5, you can fit a model. Step number 6, you can pass test value to predict the predicted score. At the last step, you can use a matrix for mean absolute error, mean square error, and root mean square error. You can predict the value. This is the very easiest example for machine learning model. I hope everyone clear on this. I'm entering into a small demo on this machine learning model. So please wait a second. So just I will open a Google. I hope my entire screen is visible. Am I right? So the first example was linear regression. I will go to my website. So just I will Google it. My name is Kesavaraja. Then I will click on my website. Then I will go to machine learning using Python. So all those examples are mapped with Colab. So I will click on the first example, simple linear regression. I will click on the first example, simple linear regression. Entire thing was mapped. So entire thing which mapped with Colab. So I directly click on my Colab experiment. So not this one. I will again entering into my website. So linear regression. So yes, initially, because I'm not using my local machine. So here I'm using a Google Colab. So because of that reason, I will map with my Google Drive. So only 2 lines I have additionally added from google.colab import drive. Drive.mount of content/drive. Okay. So inside that content/drive/my drive dataset, I will upload my Excel file, that is studentscourse.csv file. Yes, okay. Only 3 line was addition to my presentation. The line number 1 from google.colab import drive. So Google Drive was connected. Then drive.mount of content.drive. Okay, that folder was mapped. Then change directory, I will map into dataset directory. Inside that already I have uploaded my studentscourse.csv. My Colab which asking permission. Yes, I will give permission and allow. So Colab was connected. Colab which connected with my Google Drive. Yes, connected. Then change directory. Okay. No such file or directory. Okay, anyway, you can leave it. If not available, I will upload again. So import the packages. Step number one, import pandas pd, import numpy np, import matplotlib.pyplot plt. Then dataset equal to pd. Yes, file is not available. I will go to my drive. I will go to dataset, students course.this, my drive/dataset. So I will check. Content drive, my drive/dataset. I think be small. Yes, okay, connected. Something. There's dataset be small. So I will change it here. So now I will import the package again. Then I will dataset d equal to pd.readcsv, studentscourse.csv. Yes. Dataset.shapeof, so which display 25 rows and 2 columns. Okay. If needed, you can plot the data. It's not mandatory. Okay. Then now I can enter into my third part. So dataset was split into 2 parts. So X and Y. So all the other column which is taken as X, only the last column which is taken as Y. So here I will execute the same. So X and Y was split. Now I will use a method that is called as train test split off method. So with the help of that, 80% data which is taken for training, 20% data which is taken for testing. I will execute. So now 80% data taken into X train, Y train variable, and other 20% data which is taken for X test and Y test variable. Then you can fit the model. So linear regression, regressor.fit of X train, Y train. Then you can predict the value. So yes, which can predict that actual Y test as well as predicted Y test. If needed, you can print DF value. Here I can find the metric value of absolute error, mean square error, and root mean square error. So this is a very basic example for linear regression. So all those algorithms, just you can change the algorithm name is enough. Everything work in a similar like this. So very easiest steps. I will repeat again. Just Google it, Kesava Raja. Then you can click on my first website. So click on materials and click on machine learning using Python. So entire materials are available here. I will click on my first experiment, linear regression. So the code which mapped with Colab. So you can click on Colab, which give the notebook link. So directly you can execute everything and everything works fine. So only 5 stages. It's very easy for learning Python in machine learning. So machine learning, all those algorithms which map with sklearn, just you can map your data, you can get a result. Then you can compare and make it in your paper. If needed, you can modify some feature selection or some other things. So this is a very basic on Python and machine learning. Any doubts, any question? Any questions? Shall I continue? Yeah. So stage number 1. So basic linear regression. So which will print. Yeah, my tutorials are available in that domain. Okay. I'm entering into my second example. It's again easiest example. Second example, I will take X and Y value. Not I will take data set. I will take X and Y value. X value are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And Y value are 1, 3, something. Y value. So this is my data set. Okay. So step number 1 for import packages. So import pandas pd, import numpy np, import matplotlib.pyplot as plt. So step number 1 completed. Step number 2, x1 comma y1, the array value which will be taken. Then you can convert it into pandas.dataframe. Okay. So now x and y which holding a frame of data is available. Data set is always no split data set is needed. Directly you can create an array and map it into data frame. Now x, y was ready. Import package, x and y was ready. Now I am using the function which is called as train test split off. I am passing x and y value. The function which is named as train test split off. Here I am passing x and y value and the test size was 0.2. So 80% data which is taken for training and 20% data which is taken for testing. Okay. So totally I am having 10 data. From that 8 data which is taken for x train comma y train. Another 2 data which is holding for x test as well as y test. Here I will use the linear regression algorithm, the same algorithm. So regressor equal to linear regression of the handler dot fit of, I will pass x train and y train. Now my model is ready. Here I will pass x test value. Here I will pass regressor dot predict of x test, which can provide the predicted score. Already y test value which hold the original score. You can compare the original score with the predicted score. If it provides accurate result, this algorithm is best fit for my data set. So the metrics are absolute error, mean square error, and root mean square error. So I will again test the second one. So I will go to again search for Google, then click on my website, then go to materials and machine learning using Python. Here there is an example for simple linear regression. I will click on here. Yeah, step number 1 for import packages. Yes, correct. Run anyway. Step number 1 is fine. Step number 2, you can create a data set and convert it into pandas data frame. Yes. Step number 3, you can split 80% data for training and 20% data for testing. Then all those things are placed here. Then you can fit a model, X train and Y train. You can predict the value. Okay. If needed, I will print the value. I will print, check X train, check the same X train. Initially, I will print X. Please wait. I will print X. X holding 10 values. Okay. I will print the X train. Which will print only 8 values. X train which will print 8 values. I think 0, 1, 2 is missing. 3, 4, 5, 6, 7, 8 is missing. 9. So 2 and 8 which will be taken for testing. I will check X test. 2 and 8 which is taken for X test. Okay. After predicting score, Y underscore predicted score, I will check. This is my predicted value, 3.9 and 10.77. Actual value, Y test, 2 and 10. Y underscore predicted score, I will execute. So the predicted score is 3.9, but actual is 2. The predicted is 10.7, but actual is 10. So this is what my algorithm works. Based on the 8 data, if data set was large, automatically the prediction was little more fine-tuned. So if, one second. So whenever you can increase the size of data set, automatically it increases. Automatically the performance metrics, the score, performance score was increased. Here this is a absolute error, mean square error and root mean square error. Any doubts, any question from participant side? So only 5 stages. The step number 1 for import packages, step number 2 for read data from dataset, step number 3 for X and Y split up. So X value which is taken as well as Y value which is taken. Then next, you can take X train and Y train, 80% data taken for training and 20% data taken for testing. Then you can fit a linear regression model. After that, you can pass X test value and predict the Y predicted score. Then finally, you can compare Y test score as well as Y predicted score, then find the final value. This is for simple linear regression algorithm. Machine learning using Python. Now I am entering into my second part. So in that website, this link also available in the same. So entire data sets are available in that website. If needed, you can click on. So the complete data sets, all those data set URL which will be provided here. Okay. So students course, bill authentication, petrol consumption, multiple linear regression algorithm, then collection of data sets here. The entire data sets are available here. Okay. So complete data sets are available in that website. If needed, you can search my website and go there and search. You can collect whatever data set you need for your project. You can collect from this website. So I will enter into multiple linear regression. Everything was same. If linear regression, multiple linear regression, decision tree, random forest, we are using same 5 steps. So now step number 1, again I am repeating the same. Step number 1 for import packages. Import pandas pd, import numpy np, import matplotlib.pyplot as plt. So step number 1 is same. Step number 2, here the petrol consumption data set. These set of columns are marked as X. This petrol consumption data which is marked as Y. Okay. Now I will download the CSV file and map into pd.read_csv. Dataset equal to pd.read_csv petrol consumption.csv. So the handler which pointing petrol consumption.csv file. The handler which pointing petrol consumption.csv CSV file. Okay. Then here I am mapping into different way. X equal to data set inside square bracket array, petrol tax, average income, paved highways, and popular. Please check. Petrol tax, average income, paved highway, population, driver, license. So these columns are mapped into X. The last column, this is petrol consumption column, data set of petrol consumption column only, which mapped into Y. So step number 1 for import packages. Step number 2 for read data from data set. Step number 3 for splitting X and Y. So step number 1 for import libraries. Step number 2 for read data from data set. Step number 3 for splitting X and Y. Splitting X and Y. All the other column which mapped into X, only the last column which is mapped into Y. Okay. Then now I am using the same method, train test split off. Same method, train test split off. With the help of that, I am passing X and Y value. Here it can split 80% data for training and 20% data for testing because the test size is 0.2. So step number 4 was completed. Step number 5, using same linear regression, I am passing all those X train and Y train value. It's trained, and I will pass the predicted value. Regressor, the model dot predict of X test, which can predict the predicted value. Actual value is 640, but here the predicted score is 643. Actual score is 464. Here the predicted score is 411. Actual score is 549. Predicted score is somewhat different. If the data set size increases, automatically the prediction was increased. So this is multiple column. Initially you are fitting with a single column X and single column Y. Now you are entering into the second part for multiple linear regression. So multiple columns. I am not entering into gradient descent. I will enter into decision tree. Please wait. So I'm not entering into gradient descent now. I'm entering into the another algorithm. So the first one for linear regression. So with a simple data set. Now you are entering into decision tree and random forest. This is our theme. So initially starts with intro of machine learning, then applications, then we are entering into basic Python, example Python libraries, and then linear regression using Python, then how to run the experiment in Colab. And now we are entering into decision tree. So here, our data set which having, please listen carefully, the data set which having 10 data. Okay, the data set having 10 data. Based on the data, you can construct a tree. Based on the data, you can construct a tree. Then, if I am pass another X value, we can find whether it's cheat or not. So here, the 3 columns which is taken as X, the last column only which will be taken as Y. Yeah, the first 3 column which is taken as X, the last column only which is taken as Y. So based on the training data, you can construct this tree. Okay, based on the training data, you can check refund. If refund is yes, cheat is no. Check refund is yes, cheat is no. Refund is yes, cheat is no. Refund is yes, cheat is no. Okay, so all those things. So tree constructor, refund is yes, cheat is no. If refund is no, I will choose another color. If refund is no, you can check the marital status, whether single or married. So if married, then cheat is no. If single, then you can check for taxable income. If it's lesser than 80K, then no. If greater than 80K, it's yes. Like this, the decision tree was automatically constructed. You can just pass the data. You can just pass the data. You can just pass 80% data for training, sorry. So just pause. 80% data for training. Then based on the training data, it can construct a decision tree. Now I will pass another data. Something. The data was refund is no. So refund is no in the sense it will move here. Status is married. Then it can move here. Then automatically the result was no. So it can provide the cheat result was no. Yes. Test data was passed. It initially which will be check with decision tree, then moved into second stage, again which will be checked, then moved into third stage, which will say the final result y is no. So whether it's in class 1 or class 2, this is for decision tree algorithm. This decision tree algorithm, which applicable for both regression as well as classification. This decision tree algorithm, which applicable for both regression as well as classification. So here decision tree for regression. Here decision tree for regression. So here there is a problem statement was given. So based on the problem statement, the data set was downloaded. I will follow the same step for this decision tree algorithm. Linear regression, I will follow only 5 steps. Multiple linear regression, I will follow only 5 stages. Then logistic regression, I will follow only 5 stages. Now I am entering into decision tree algorithm. The same 5 stages also followed here. So step number 1. Step number 1 for import library. Step number 1 for import libraries. Import Pandas as speed. Pandas library which used for 1 second. So Pandas library which used for handling data frames, then NumPy for arrays, Matplotlib.pyplot for visualizing your data. So step number 1 is similar. Step number 2, I have downloaded the data set from my dataset URL, and then I will place it inside my folder or Google Drive. Then I will place dataset equal to pd.readcsv petrol consumption.csv. Now my handler which pointing my dataset. So step number 1 for import package. Step number 2 for read data from dataset. This dataset was petrol consumption.csv which pointed by my handler. Then step number 3, all the other column which is taken as X, only the petrol consumption, the last column which is taken as Y. So X and Y was fine. So all the other columns which mapped into X, only the last column petrol consumption which can predict. So that's for regression. So you can predict the Y petrol consumption value. So Y predicted score. So all the other column which mapped into X, the last column which mapped into Y. Then here there is an algorithm which is called as train test split off. Train test split off. I will pass X and Y value and test size as 0.2. So here 80% data from petrol consumption CSV which taken for training, and 20% data from petrol consumption.csv which taken for testing. So 80-20 rule. So 80% for training and 20% for testing. So fine. So step number 1 import package. Step number 2 for read data from dataset. Step number 3 XY split up. So fine. Then step number 4 for 80% data which taken for training and 20% data which taken for testing. Then now one and only a single line change. Regressor equal to, there we will place linear regression. Here I will place decision tree regressor off. So I will create a model regressor.fit off, X train, Y train.